GATE Aerospace Engineering, and many of you may find it's a tough subject, right? Who all are agree? Is it tough subject? Aircraft structure is tough subject or easy? Yeah, because in aircraft structures, nothing is to mug up. You have to understand mathematics and physics of every concept. Lot many derivations will be there. You need few things like you need to be good in, you know, some free body diagram and some sign convention. We follow standard sign convention, and you need to be good in mathematics. If you are good in these three things, you can secure all marks in this SOM or structures. But yet I have to see the GATE 2021 paper. People have said structures was very tough. Okay. But in structures, there are three portions. One is a basic strength of material part, which is relatively easier. Then we have vibration part, which is also quite lengthier in our GATE Aerospace Engineering. And then we have thin walled structure. So thin walled structure is of course tough because lot much calculation has to be done in every questions, and questions will be quite lengthier. If you wish to work in aircraft industry, especially in aerostructure, where I have worked more than 8 years, you need to be very good in thin walled structure. In day to day, also you will use all the formula which we are going to derive in our GATE classes, or we have been, learning in our engineering, like unsymmetrical bending, shear flow, torsional shear flow, and many other things. In fact, what all we discuss in strength of material or basic elasticity, everything is used in industry directly. Okay, or if you go for any interview, they will ask questions from what we discuss here. Okay, so let's start with a simple topic. Okay, let's start with a simple topic. Yeah, so stress strain relationship. So how many of you are aware about stress strain relationship, guys? All of you know Hooke's law. What is the Hooke's law, guys? What is the Hooke's law, guys? What is the Hooke's law? Yes, stress is proportional to strain, right? Like sigma is proportional to epsilon. But where it is applicable, guys? It is for 1D loading. Am I correct? Like from here what we find, sigma is equal to E times epsilon, right? So what is, guys? Sigma is equal to E times epsilon. Am I correct? So what is E here, guys? Yeah, we are talking stress-strain relationship for isotropic material. Because from this simple concept, they have asked many times questions. So what is E here, guys? Yes, Young's modulus. It's known as Young's modulus or modulus of elasticity. But as I said, this Hooke's law is applicable only for 1D loading. Now suppose you have two-dimensional loading. If you have two-dimensional loading, or if you have three-dimensional loading, then tell me, can we apply this Hooke's law? Can we, guys, apply Hooke's law? Or can I say my stress is directly proportional to strain? Anyone? Abhiram Chandra. No, you cannot, right? Because what happens, I will take one two-dimensional case. Suppose I have one plate and it is subjected to my stresses sigma x and sigma y, right? So I have two stress, sigma x and sigma y. So it is what two-dimensional stress system. Clear? Now in this case, tell me, guys, what will be your strain? What will be your strain? I want suppose epsilon x. Will it be sigma x upon E? Because from Hooke's law, right? This is what should be your strain. But is it the case? Anyone? Yes or no? No. Or yes? No. It is not the case. What will be my strain? It will be sigma x by E minus nu times sigma y by E. So there is one additional terms. What is the additional term? Is due to my stress in y direction, there is strain in x direction. Due to what? Poisson effect. Due to what? Poisson effect. Is it clear? Is this point clear? Due to Poisson effect, I have one additional strain in x direction due to loading in y direction. Is this clear, you guys? Now tell me guys, why it is negative? Tell me guys, why it is negative? Why it is not positive? Can you understand physically? You guys see here, when I apply this sigma x, what will happen? It will get extended. Am I correct? So that is means strain is developed. Now what happens? This sigma y will oppose what? This extension, right? Means this contraction. Clear? So that means your strain is reduced when sigma y is present. That's why you can see here negative sign. Is it clear? Is this point is clear? So physically also we can understand when there is a plate, when there is a plate, when there is a plate and if it is subjected to stress in two direction, then your strain in one particular direction will be lesser if instead of this 2D, if it is subjected to 1D loading. Clear? Right? Because this guy is restricting motion in x direction. Okay? So this is what our physical understanding why this negative sign is present here. Okay? So this is how we derive stress strain relationship for 2D stress system. So this is what your epsilon x. Now tell me guys, what is your epsilon y? My epsilon y will be sigma y by E minus nu times sigma x by E. Is it clear? Is it clear or not, guys? Quickly tell. See, guys, be interactive, okay? We are online, but still interaction must be there, okay? That's how we enjoy, okay? So good. Now, this I talk about two-dimensional stress system. Now, suppose my stress system or my loading is three-dimensional, right? If my loading is three-dimensional, that means I have sigma x, I have sigma y, and I have sigma z. How I can visualize if I take a cuboid? So suppose here you have sigma x, here you have sigma y, and on this face you have sigma z, right? Is it clear? The loading part, is it clear, guys? You have one stress in x direction, sigma x, I can write here. Then you have sigma z and you have sigma y. Right. So in this case, what will be your epsilon x? It will be sigma x by E. Then due to Poisson effect, you have minus nu sigma y by sigma E minus nu times sigma z by E. Is it clear? Is it clear or not, guys? Then similarly, I can write epsilon y, which is what? Sigma y by E minus nu times sigma x by E minus nu sigma z by E, and then I can write epsilon z, which will be what? Sigma z by E minus nu sigma x by E minus nu sigma y by E. Is it clear? So I have three strain term, right? You guys can see epsilon z, epsilon x, epsilon y. I can write these three equation in a matrix form. Is it clear? 1 by E can be taken out. So it is what? 1 minus nu, then minus nu 1, minus nu, minus nu, minus nu 1. Is it clear? Yeah. Nu or mu is what? Poisson's ratio. So this form is easy to remember. In matrix form, we can easily remember. And in this form itself, in GATE 2020, they asked a question. In GATE 2020. In GATE 2020, there is a question. We will solve that question, okay? We'll solve that question. Clear? Okay. Now, guys, this here, what I have done, I have written my strain in terms of stresses. You can write by taking inverse of this matrix stress in terms of strain. So both the forms are very important in GATE exam to remember. In this, it is 1 by E. Here, my constant is E upon 1 plus nu into 1 minus 2 nu. Then it can be remembered because again, it's a symmetric matrix 1 minus nu, 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 1 minus nu, nu, like that. Okay, so these are the two equation for stress strain relationship and strain stress relationship. So based on this, we have two concepts. One is what? Plane stress problem, and one is plane strain problem. So we have seen the questions from these two concepts in previous year's paper, as well as directly question from this form. Okay, from this form. Okay, so we will take up those questions. Before that, if someone asks, why do we study, strength of material or aircraft structure? Anyone? Why do we study this subject in our aerospace engineering? Can anyone answer? What is the significance or importance of this subject? To me, it is, guys, very simple. Your aerodynamic sir will give me loads. Okay. Your aerodynamic sir will give me what? Surface loads. Okay. And body loads. Okay. Body loads are what? In broadly, we can categorize loads in two forms. One is body forces and one is surface forces. So body forces are what? Forces due to gravity, okay, or forces due to inertia. What is surface forces? You have force due to pressure or you have shear stresses, right? Those are surface forces. So what I have to do as an structural engineer, I need to analyze for applied loads, my structure is safe or not, or my design is satisfying my goal or not. Am I correct? Right? What your CFD team gives, CFD team will give us load, and as an structural engineer, what I will do for my every component of aircraft, I need to check something called margin. Have you guys heard about margin? What is the margin? There is something called margin of safety, factor of safety, right? So MS, factor of safety, FOS, or RF, reserve factor. Have you guys heard about these three? So my job is to find any of these three. All three means same. Only it's a different. The different company use the different name. Some use margin of safety, some use factor of safety, some use RF. Okay. So what is margin of safety? Relation between margin of safety and factor of safety. Anyone? Anyone have come across these terms? See, margin of safety is nothing but your FOS minus 1. Factor of safety minus 1 is what? Margin of safety. Yeah, you are correct, Jay Verma. Yeah. And FOS has to be always greater than 1, or your reserve factor should be always greater than 1. But your margin of safety has to be greater than 0. Okay, so this is what the difference. Okay, different company use different notification. So the whole idea to study this subject is to find always margins. Clear? Always check your structure is safe. How we find safe? We compare our maximum applied loads or maximum stresses. Okay, like you guys might have heard about von Mises stress and principal stress. So we compare this quantity against what? Material allowable. Okay, and we find the margins. Clear? Okay. Now here we are discussing about stress-strain relationship or strain-stress relationship. So I told from this there are two conditions come across. One is a plane stress problem and one is a plane stress problem and another is plane strain problem. One more thing I want to tell here, guys, we have seen these relations are between, you know, your normal stresses to normal strain. But there is something called shear stresses and shear strain also, right? You guys know? There are shear stresses and shear strain, guys. So what is the relation between shear stresses and shear strain? Anyone? What is your tau xy? What is the tau xy, guys? It is G into gamma xy. What is your tau yz? It is G into gamma yz. What is your tau zx? It will be G into gamma zx. Now what is the G, guys, here? What is the G? Yes, it's a bulk modulus. And we are going to derive also this relation, how we have got this relation between shear stresses and shear strain when we start our class. But between, what is the G and relation between E? We know what is G. G is E upon 2 into 1 plus nu. Do you guys know this relation? Do you guys know this relation? G equal to E upon 2 into 1 plus nu. This again we are going to derive. Okay, this again we will derive when we start our real class. Okay, here my idea was just to give you essence and see how gate questions are. Now, based on this, I will solve one previous year's questions. Yeah, guys, look this question. This question is from GATE 2020. Guys, can you try this question now? Now tell me, guys, I have already given you guys in matrix form both normal strain to normal stress, and we can write also shear strain to shear stress. So tell me, guys, what is A here? What is the A, guys, here? Anyone? What is the A? No, afraid, just think. A is 1 by E, not E. So guys, we know what is the epsilon x. Let's write epsilon x is what? Sigma x by E minus nu times sigma y by E minus nu times sigma z by E. Correct? Is it correct? Yes or no? So what is your A? A is 1 by E. What is C, guys? It is minus nu by E. Now tell me, guys, what is the B? B is 1 by G. Am I correct? Because we know what is the gamma xy. What is the gamma xy, guys? It is tau xy by G. So what is the B? It is 1 by G. And what is the G we have written, guys? So it is 2 into 1 plus nu by E is what your B. Right? Am I correct? Yes or no, guys? Quickly tell yes or no. Okay. What I need to repeat, what is your name? C. C is, guys, here this equation is there, na? Minus C. C into sigma xx. So what is C? No, see, I will explain you what is the shear stress and what is normal, then you will see. The Poisson effect is not related with shear stress because shear stress doesn't change volume. It only distort your structure. The change in volume is only caused by normal stresses. So Poisson effect doesn't come in shear. So J, now is it clear how my C is minus nu by E? Clear? Now my B is what? 2 into 1 plus nu by E. So I can write it like this. B by 2 is what? 1 by E plus nu by E. Now guys, what is the 1 by E? 1 by E is A. What is the nu by E? It is C. So what I got from here? B by 2 is equal to A plus C. So what is my C from here, guys? My C is A minus B by 2. So tell me what is the answer, guys? What is the answer? Everyone, please tell quickly what is the answer? So is it clear? Was it tough question? If you have clear understanding of the concepts, it's the easiest question. And it came for how many marks? 2 marks. Now tell me, guys, was it tough to secure these 2 marks? Was it tough to secure 2 marks? And it's very interesting, right? What I need to explain B? Okay, Shreyas. B, right? What is gamma xy? What is the gamma xy? It is tau x by G. Now you see this matrix. What will be gamma yz? It will be B times tau yz. What is a gamma xy? B times tau xy. Then tell me what is the B? What is the B, Shrey? B is 1 by G, right? Is it clear now? Clear. Now we know what is the G. G is E upon 2 into 1 plus nu. So is it clear how to solve this question in a simplest way? You just need to understand what this matrix form, right? So these matrix form we already know it is these are the relation between strain and stresses. Is it clear? Yes or no? Everyone? Okay, fine. So can I move to next concept? Right. So let's go back to stress strain relationship, and I told the application of stress strain relationship we use in plane stress problem. So can anyone tell me what is the plane stress problem? What is the plane stress problem? Anyone? No. Afraid 2D problem can be plane stress also, it can be plane strain also. Okay. We have to be very specific about plane stress problem. So plane stress problem means what? You guys, you can have three directions, right? X, Y, and Z. If my stresses in Z directions are 0, what all stresses you can have in Z direction? One is sigma Z, then you can have tau Z, XZ, and you have tau YZ. If all three are 0, then it is known as plane stress problem in what? XY plane. Clear? Because in this case you have only non-zero stresses in what? XY plane. So this is known as plane stress problem in XY plane. Is my voice is clear? Okay, so is this clear? What is the plane stress problem? Now in your aircraft is a thin walled structure. So your aircraft structures in thin walled, we always have plane stress problem. We will not have stresses along your thickness direction. Okay, we will neglect our stresses across along thickness direction. You will have your stresses in plane. Okay, because if you take in plane direction as a XY plane, then you will not have these three. Now guys, suppose my plane is YZ, my X. So in this case, suppose if your sigma X, tau XY and tau XZ are 0. Now tell me guys, this problem is plane stress problem in what plane? In what plane? Yes, it is plane stress problem in YZ plane. You are very correct. That's good. That's good. Now guys, tell me, for a plane stress problem in YZ plane, will you have epsilon Z 0 or non-zero? Anyone? 0 or non-zero? Yes. So what we are saying, for a plane stress problem, you can have a epsilon Z, which is what? Strain in Z direction non-zero. From where? We can see it from stress strain relationship. My stress in X and Y direction produces strain in Z direction. Clear? So for a plane stress problem, if I consider my XY plane, if I consider my here actually, since plane was YZ, so I should have told epsilon X. Okay, because here perpendicular direction is X direction. But if you consider XY plane, if you consider XY plane, if you consider if you consider XY plane, so in XY plane, what is your epsilon Z? Your epsilon Z from stress strain relationship will be given by this equation, right? So though it's a plane stress problem or it's a 2D problem, but you have epsilon z due to what? Poisson effect. So what it is? It is minus nu times nu by E sigma x plus sigma y. Is it clear? Is this clear to everyone? Okay. Now, what is the application of plane stress problem? There are many application of plane stress problem. One is our thin walled structure, aircraft structure. Okay. Now you can see, beam problem, you know beam problem, your thin cell, right? Spherical cell, cylindrical cells, all these are what? Plane stress problem. Now, once you know the plane stress problem, next concept is what? Plane strain problem. So what is the plane strain problem, guys? Now tell me. What is the plane strain problem? Anyone? In plane strain problem, what will happen? You will not have strain in perpendicular plane. Suppose this is my xy plane, then my epsilon z, gamma yz, gamma xz will be what? 0. But what? Your sigma z may not be 0. Is it clear? Your strain in perpendicular direction will be 0, but stress may not be 0. How? Again, it is from stress strain relationship. So what we see, non-zero stresses can be sigma x, sigma y, sigma z and tau xy, but non-zero strain will be what? Only in plane, which is epsilon x, epsilon y and gamma xy. Now you see your stress strain relationship. What is your epsilon x? It is 1 upon E sigma x minus nu sigma y and sigma z. I don't know about sigma z as of now. As of now, I don't know about sigma z. Now what will be epsilon y? It is again 1 upon E into sigma y minus nu times sigma x plus sigma z. But I don't know about what? I don't know about sigma z part. Is it clear? Now, how I know about sigma z? You guys know what is your epsilon z? It is 0. So 0 equal to 1 upon E sigma z minus this term. So from here we get sigma z equal to nu times sigma x plus sigma y. Now again, this is one of the GATE question and it came in GATE 2009, the year in which I appeared, GATE 2009. Okay, so can we see that question? Let's see that question, guys. Can you see this question? Read it and give me the answer. What is the answer, guys? See, in plane stress problem, stresses will be 0 in perpendicular direction. Okay. What is your doubt, Abhiram? Is it the same in plane stress problem? Stress in perpendicular may not be 0. I don't know. I am asking what you don't know. plane stress problem itself says your stresses are in perpendicular direction 0. That is what the condition. Then why you are asking this, Sam, Abhiram, any? Is it clear? The definition of plane stress itself says your stresses in out of plane directions are 0. Is it clear? But you can have non-zero strain, which is what? Epsilon z, if your plane is xy plane. Is it clear, Abhiram? Yes, B is the answer. Okay, I will explain you guys this question. Now here plane strain problem, the satisfies condition. So guys, for plane strain condition we know sigma z is non-zero. A cannot be the answer. C is not the answer because we know sigma z was what? Nu times sigma x plus sigma y. D cannot be the answer, right? So what is the answer? B is the answer. Why B is the answer? Because we know gamma xz and gamma yz are 0, right? So that means what? Tau xz will be 0 and tau yz will be also 0, and we have already known sigma z is what? Nu times sigma x plus sigma y. Is it clear? This is for what? XY plane. Is it clear this question, guys, everyone? So this is how in GATE they ask questions. Was it tough again? I don't think it was a tough question. If you are clear with concepts, it's quite easy. Fine? Fine, guys? Okay, so that's good. Now, let's look one more question. Yeah, look here, these two easy question. Okay, first question you can leave. Tell me the answer for question number 2. Because we have now, for first questions, we haven't discussed anisotropic material. So what they told, for a plane strain problem in XY plane, in general, the non-zero stresses are what? We know sigma XX, sigma YY, sigma ZZ, and sigma XY. So which is the correct answer? I think I need to zoom it, right? So D should be the answer. Why C? Someone has told C is the answer. Okay, let me zoom. Okay, let me zoom this. Okay, let me zoom this. One moment. Yeah, tell me the answer, guys. So what is the non-zero stresses for plane strain problem in XY plane? Abhiram, do you think sigma x z is non-zero? How C is the answer? Guys, what is, okay, leave the answers, forget the answers. Tell me with your concept, what is non-zero stresses? Non-zero stresses for plane strain problem in XY plane are what? It is sigma XX, sigma YY, sigma ZZ, and what? Tau, tau XY, or what you can say, sigma XY. Clear? Is it clear? Yes or no? Clear? Right. So what is the answer? Abhiram, what is the answer? D is the answer. You can see here sigma xx, sigma yy, sigma xy, and sigma zz. Now here instead of tau they have written sigma. That also I will explain. Either you can write tau or sigma. That doesn't matter. What matters? This prefix I and j. If I equal to j, then it is normal stress. If I is not equal to j, then it is shear stress. So what is the answer? Finally, what is the answer, guys? What is the answer? The answer is D. What is the answer, guys? Answer is D. So that's it from my side for today's class. Okay. And I gave the